Hello, everyone. I'm Vijay Kumar. I'm the Dean of the School of Engineering and Applied Science at the University of Pennsylvania. I'm a professor in mechanical engineering and applied mechanics. I also have appointments in computer information science and in electrical and systems engineering. I'm delighted to welcome you to this open house. And I also want to commend you on your decision to pursue an advanced degree in engineering. And thank you for considering Penn Engineering as a candidate school. I know I'm biased, but I feel like Penn is the best institution for you to earn a PhD degree in engineering. And let me give you 3 reasons for that. First, we are a vibrant community of over 11,000 graduate students. And we have over 4,000 faculty that interact with the 11,000 graduate students across 12 schools. Of course, engineering is only one of the 12 schools, but today, engineering has extensive collaborations with all these schools. Indeed, the word interdisciplinary was being used at Penn long before it became a buzzword. It's part of our DNA. Our faculty and students have collaborations across departments and across schools, and this is the norm rather than the exception. My second reason, and maybe this is the reason for the interdisciplinary culture that we have, is the proximity across campus. If you want to go from any point on campus to any other point on campus, it's at most a 12-minute walk. And there's a level of intimacy, even though we're a large community, that you get on the Penn campus. The third reason is that Penn is part of Philadelphia. We're an urban campus. And as you think about a university or a city where you might spend the next 4 to 5 years of your life, it's really hard to beat this combination of Penn and Philadelphia. Penn's opportunities for collaboration and innovation are limitless. The school is centrally located in a growing technology hub of Philadelphia with numerous startups and industry connection points. As a Penn engineer, you would join a powerful global network of scholars dedicated to our mission, the mission of developing and advancing solutions to society's most pressing problems. Indeed, none of the global challenges that we face can be overcome without engineers. And engineers have already played a very essential role in the key advancements made by mankind. We stand on a proud reputation of these achievements, with one of the most notable being ENIAC, the first digital computer which was developed right here at Penn in the 1940s. This culture of path-breaking innovation continues through today, the current era, where in 2020, the 30-year-old idea of injecting modified RNAs into the human body to engineer designer proteins came to fruition. This resulted in the highly impactful development of a COVID-19 vaccine, which won a Nobel Prize. This was breakthrough research conducted right here at Penn. And today, the scientists in Penn Medicine work with engineers in our school to engineer nanoparticles, novel drug delivery techniques to deliver modified RNA for other kinds of diseases. My colleagues will speak on the specifics of our degree programs, but broadly, each doctoral student in our school is mentored by 4 experts in the forefronts of their fields. And we have a forward-thinking, interdisciplinary culture that we're proud of. And because of the talent, dedication, and creativity of our PhD students that we recruit, the most exciting, transformative projects with the highest risk and reward are carried out right here. Our research initiatives can be grouped into 3 areas. First, engineering health, indeed engineering human health, data science and AI, and energy and sustainability. Currently, we're in a period of unprecedented growth in the school's physical plant and faculty hiring. In the next 12 months, we will see 3 new buildings going up: the Vagelos Laboratory for Energy Science and Technology, Amy Gutman Hall, our future home for AI and data science, and a new laboratory for the Center for Precision Engineering for Health. These state-of-the-art new facilities, along with record numbers of world-class faculty that we're recruiting to Penn Engineering, reflect our investments in areas that are critical to the future of humanity. As doctoral students, you would join our school during the most exciting time in our history. Of course, I am proud to lead the school during this transformative era, and even prouder to represent the 800 to 900 doctoral students who are part of our community. Before I pass the podium on to Dr. Boon-Tao Liu, our Associate Dean for Graduate Programs, I'd like to extend to you my good wishes as you pursue your future careers. I want to thank you for considering Penn Engineering for your doctoral studies, and I do hope I'll be able to see you in next fall. Thank you.
Special thanks to Dr. Kumar, who was not able to join us, but who recorded that welcoming remark for everyone here. I'm just going to move us forward. We have Dr. Liu, who's the Associate Dean of Graduate Programs, who will be providing us with some information about preparing for graduate studies.
First of all, I'm so happy to see everyone here. I am delighted that you're considering Penn Engineering for your PhD studies. And today I will give you some quick sneak preview of what it's like to be a PhD student at Penn. Now, as Dean Kumar mentioned just now, we are highly interdisciplinary. And I think this is best reflected in our 6 PhD programs, which we refer to broadly as graduate groups. And this is one distinction you will see at Penn compared to maybe some other universities elsewhere, where we don't really have silos by departments. So the 6 graduate programs that we have are bioengineering, chemical and biomolecular engineering, computer and information science, electrical and systems engineering, material science and engineering, and mechanical engineering and applied mechanics. Now, these silos are actually very loose boundaries. So for example, I myself is a primary faculty in computer science, but I also have a secondary appointment in electrical and systems engineering. And I regularly advise students across both departments and sit on dissertation committees and so on. Bioengineering graduate group actually is very broad. It involves many faculty all across campus in the med school and elsewhere. So they work closely with our bioengineering faculty, who many of them also have joint appointments across different departments. And I think this really leads to very interesting interdisciplinary research, where a lot of the cutting edge innovation really happens across disciplines. And Senior Associate Dean Professor Dave Meany will talk about our various research centers. And I think those you can really see how they showcase the interdisciplinary cross-cutting nature of our work. So it's like to be a PhD student at Penn? The first thing to note is that all of you are fully funded while you're at Penn. So funding is not something you have to be concerned about. Many students in their first year will undergo lab rotation or embed in research labs and centers. And as a first-year student, while you may have put in your application your interest to work with particular faculty, do know that in your first year, you have the opportunity to explore, learn about what Penn Engineering has to offer. Maybe you decide that the lab that you applied into is the best option for you, or you may decide there could be another faculty that's a better fit for your interest, or you may even end up being co-advised by different faculty members. So year 1 is for you to explore and also take classes, and many of our students regularly attend research seminars as well. And there's also different exams that you will need to clear in the first and second years. But we have a great support system in our school to try to make sure our students can meet these milestones. And also, depending on the department or graduate group, some students may be required to do teaching practicum. And it is essentially working as a teaching assistant to help faculty in their classes. And many students find that a very rewarding experience where they get a chance to interact with students and help educate the next generation of undergrads. Year 3 and 4 is where you start searching for a research topic. And this is also where you assemble a thesis committee to help you on your research. So while you are at Penn, you will not only have the support of your faculty advisor, but also your lab mates, your fellow students, and also a committee of faculty. Some of that may be in your research area or could be adjacent or a little bit further away. And they serve as your support network to help you succeed. And year 5 onwards is where you become the expert. And I always tell my students, by the time you graduate or close to graduation, all of you are expert in your research area. You know the topic way more than I do. And that's where you know it's time for you to graduate. Now, every department also regularly have kind of a department-specific evaluation of PhD students. This is where we get together to discuss the progress of our students. And if there are some students that may be struggling or having some challenges, we will together collectively come up with ideas to help provide support for the students to make progress. So overall, the moment you step into Penn Engineering, we have only one goal, which is to help you succeed and fulfill your lifelong ambition of getting a PhD and whatever career you would like to pursue after that. We have a great community in the engineering school. So I'm just naming a few, and one slide is barely enough to do justice. So, but I'd like to mention a couple. So we have the Graduate Student Engineering Group. So this is otherwise fondly known as GSEC, and it consists of a group of students, they're volunteers, and they get together to organize social events, TGIFs, various get-together for students throughout the year. And GSEC also has individual graduate group representation. And so this is oftentimes a chance for students to mingle, have food, talk to each other, exchange ideas, and so on. And separately, there are various boards, student-led boards that are really influential in shaping policies at the school level on graduate education. They include the Dean's Doctoral Advisory Board, the Dean's Doctoral Diversity and Inclusion Board, and the Engineering Masters Advisory Board. So I, as Associate Dean for Graduate Programs, regularly meet the board members, and they have been very helpful in shaping policies that can improve the life of students. So for example, we started a research support plan mechanism to help struggling students. Stipend for PhD students was significantly increased over the last 2 years to take into account the cost of inflation. And also we started adding dental insurance coverage for all PhD students. And the board has been really helpful. And if we are lucky enough to get you to come to Penn, I will certainly hope some of you will be willing to step up and participate in the board. It's a great chance to get some leadership opportunities as well. And I myself and our advising staff, and I speak for not just advising staff at the school level, but also in the front lines in every department, all the graduate coordinators. We are here to support and improve your lives. And many of us hold regular office hours where you can drop in, chat with us, any difficulty that you have. We love to help and support you. I very much look forward to your application, and I'm going to hand this back to Christina.
Thank you, Dr. Liu. All right, now we'll hear from Senior Associate Dean, Dr. Dave Meany, who's going to talk about integrated research at Penn.
Thank you, everyone. And Boone gave a wonderful intro to really many of our values as a community here, as faculty and staff, and the support that we provide all of our students as they progress through that journey. And as Boone said, fulfill that aspiration that they've had to earn a PhD in a particular engineering or science field. And we're very supportive of building a person as they go through the years. What I want to talk about today, and I'll touch on some of the themes that Vijay Kumar talked about in his opening statement, that we're a school that really values how do we apply engineering and science knowledge into problems of both today and the future. And so it's this notion that we certainly develop the theory and understand some of the fundamental mechanisms, but we're always mindful about how some of the work can impact the world that we live in, both now and in the future. So what I'm going to talk about is 3 different areas that align with those 3 areas of impact. I just want to reiterate what Boone also talked about, the way in which we do this, the way in which we support our graduate students on their path to becoming independent thinkers and people whose work on their own impacts the world. We have these graduate groups, and the graduate groups provide us with an enormous flexibility, one of which is that it gives you a large number of faculty that can be and can serve as your PhD advisor. We're a school of about 150 faculty right now, but we have over 400 faculty from across the university that can serve as your advisor. We really emphasize, and we're known for having programs which are highly cross-cutting and involve many of the other schools here at Penn. And then finally, as I was mentioning, what we want to do is we want to do this research with a purpose so that it has some application in society. There's really 3 areas I'm going to talk about when I talk about those application areas. The first is in our health as a population. The second is in protecting and preserving the physical world that is surrounding us, thinking about areas like climate change. And then finally, I think it's unmistakable that we're also creating what I would call a digital world to complement our physical world. And this digital world, and in particular using data science and AI and all of these other new or newer disciplines, is really shaping the ways in which we think as a population and as individuals. And I'll talk a bit about some of the work that we have here at Penn within the engineering school in shaping that digital world. So I want to first start with an example that connects our school into the health schools at Penn. So Penn has a unique campus. We have 12 total schools. 4 of those schools are actually health-related schools. The School of Nursing, the School of Medicine are primary partners among that. What we have is a number of faculty that not only think about some of the problems and reduce them down to some basic fundamental phenomenon, but we also have faculty, one of whom is pictured here, that think about how do I create technologies that can have some commercializable value to the community. This emerged from the pandemic. Cesar de la Fuente is a faculty member that's part of 2 schools, the engineering school and the medical school, and he created a paper-based diagnostic for all types of viruses, including SARS-CoV-2. And the initial application that he had caught the interest of some venture capital groups. It was supported. He was also the winner of what we call the NEMO Prize, which is the Nemirovsky Engineering and Medicine Opportunity Prize. And he's actively translating this technology so that not only for the next pandemic, but also in the seasonal flu season, we can have an idea whether we test positive for any of these viruses that are around us. Our school has grown quite a bit in supporting the type of startup activities. Startup activities are things that our younger faculty in particular are becoming very interested in and taking advantage of. This is one of many examples. And I also list a couple of other examples that touch into other areas of our application areas as a school. So it's a very vibrant activity. I mention that here because often what happens as that commercialization occurs is that PhD students graduate and then become part of startups. maybe even co-founders with some of the technology. What's happening now in Philadelphia is an incredible interest in life science technologies that border our campus. Market Street, which is a street 2 blocks north of our campus, is being revitalized right now, where there's private developers building about 5 million square feet of lab space. We've leased space. This is one of the building projects that Vijay mentioned in his opening remarks. This is the Center for Precision Engineering for Health. And our vision is that we will have laboratories, graduate students, faculty that are literally decorating this avenue of technology, and in particular, life science technology, as early as next June and going well into the future. So this is an incredible opportunity to have even more impact on not just the science as it translates into applications, but also the regional economic development in the area. A second area that I want to point out is some of the research that we do in support of improving our physical world. We have a very large grant that's called an Engineering Research Center grant, or ERC, from the National Science Foundation. The main purpose of this grant is to create an entirely new class of sensors, which are both micro and nano in scale. And those sensors are really part of our built environment in agriculture. And the whole purpose of this is to bring these sensors and to invent a new class of sensor that help communicate to farmers that are out in rural communities. What's the condition of their soil? When do they need to water their crops? What are some of the nutrients that are found in the soil as the crop goes through its growth cycle? And to connect all of these using Internet of Things technology, or IoT technology, so that a farmer has a real-time update and can customize the cultivation of their crop and the maximizing of the efficiency of their crop to produce food for the region and for the world. The US has always had a primary position in providing food for the rest of the world. This technology, we think, is the next generation technology that will revolutionize agricultural technology broadly, and it's being built here in engineering. You can easily see the same base technology as ways of monitoring our climate, the way that we consume resources, and the way that we can also manage some of these resources well into the future. And then finally, as I mentioned at the beginning, a third pillar of our work is in this emergent digital world that is really surrounding all of us. We've heard a lot of conversation in the popular press about artificial intelligence, large language learning models, and ChatGPT is just one manifestation of that. We've been studying this for some time here at Penn. We're certainly not the only place, but one of the things that we've done is we've really considered, as AI-based algorithms are being propagated out into public use, how do we as researchers ensure some of the characteristics that are necessary to embed in this? How do we create those? How do we monitor that? And how do we apply those to areas, say, such as health, medicine, or for that matter, the environment? So we have a center here that I'm showing you, which talks about AI systems that are safe, explainable, and trustworthy. So the acronym is ASSET. It's led by Dr. Rajiv Vellore. And what it really talks about is not creating algorithms, AI-based systems that are impenetrable, that they provide an answer, but we don't know how that answer was created. And instead, we create these systems which help protect information for privacy concerns so that they're safe in that regard. That they also might be safe if an AI-inspired algorithm is part of a medical device. We also consider health safety as part of that. And in particular, that they're both explainable. We can understand why we received a particular result from this algorithm, and then finally trustworthy. The real beauty of something like this for a place like Penn is that this type of work is not at all constrained to the engineering school. And in fact, its success is reliant on connections to all of the other schools that I was mentioning earlier, not just health, but for instance, in political science and the humanities, how do we rediscover the origins of our world using some of these AI-based systems? So that's incredibly exciting for us that we can build this ecosystem here, and of course, provide the next generation of investigators, our PhD students, with this kind of environment while they study for their PhD. One of the key cornerstones of this effort is a new building. Again, Vijay mentioned this. These are some illustrations of what this building will look like. This is a mass timber construction building, which means that it's an environmentally sound building, and that we have the structure of the building made from timber itself rather than concrete and steel. This will be at least a LEED Gold, and we're reaching for a LEED Platinum building. But most importantly, it's a people-centric building. What we have here are some illustrations about what the lobby looks like, what some of the areas look like for the research labs. You'll see that it's very light, open, and airy. This is our connecting node. As I show here, this is where the building is on campus, AGH, or Amy Gutman Hall. And these are the connections that we have already made with other disciplines throughout campus. This is the spread of the entire campus. And we expect this network diagram, if you will, to densify considerably as we open up Amy Gutman Hall. And this will be open next fall, scheduled for completion. So we're incredibly excited that not only do the areas of work that we do connect across campus, but we have spaces now to host those kinds of activities. So I want to finish and just let you know that there are really 4 characteristics that we've often thought of when we think of a Penn Engineering PhD. Of course, we're giving you the depth of knowledge in a particular field. Our whole curricula are designed around developing you as an independent thinker, and that you can take those creative ideas that you have and connect them to impact ideas across campus. And that, as Boone mentioned, we're really most focused on helping you develop as a person and as a student, and that give you the preparation for the next career step, whatever that may be. We've had people go into industry, academia, private foundations, think tanks. There's a number of different opportunities, and the opportunities are growing over time. I just finished with my last slide. If any of you have any questions, I certainly appreciate the time that you spent listening to me. Please feel free to email me. I'd be delighted to talk more about the initiatives that I summarized here and any other things related to Penn Engineering and the PhD programs. So Christina, thank you. I think I'll just finish right there and stop sharing.
All right, great. Thank you so much, Dr. Meany. We will now hear from Dr. CJ Taylor. He is the Associate Dean of Diversity, Equity, and Inclusion here at Penn Engineering, and he's going to speak to you about some of our Penn values.
Hey, wonderful. Thank you very much, Christina. I hope you all can hear me. Again, I really want to thank you for taking the opportunity to spend some time with us. And I want to talk a little bit about the office that I currently lead. So I'm currently, again, a faculty member in the Computer and Information Science Department. My research interests lie in computer vision and robotics, but I'm also sort of honored to be the Associate Dean for Diversity, Equity, and Inclusion here at the University of Pennsylvania School of Engineering and Applied Science. And I think the first thing I want to tell you about this is that our office actually has a history dating back at least 40 years. It was actually founded by then Dean Joseph Bordonia and Cora Ingram. And at that time, it was referred to as the Office of Minority Programs. But in substance, the goals of the office have been really the same since its inception. This is an office that's open to all students across the School of Engineering and Applied Science, and sort of focuses on belonging, on supporting students, on building a sense of community to allow people to sort of do their best work. And I think that's really what we pride ourselves on. Currently, the office has a number of staff members, seen here. The director of the office, senior director of the office, is Dr. Laura Stubbs, who's on this call. We have a number of really talented and committed staff members who focus on various aspects from undergraduate support to Dr. Osakeki, who's actually focuses on supporting graduate students in a number of different ways. We have a director of outreach and community engagement. We have ties to advising and other offices. And I would also say is that while my office, ODEI, is a school-wide initiative, we also have very tight interconnections with the individual departments. So in every single department in our school, we have a DEI liaison, who's a faculty member who meets with us on at least a monthly basis. And there are actually individual DEI committees in several of the departments that are also extremely active. So this is something that we've sort of embedded throughout our school. These are just a couple of pictures from our 40th anniversary celebration. On the left, you'll see our founders, Dean Bardonia and Cora Ingram. And on the right, you'll see the opening of our new space, which we're actually quite proud of. So if you have a chance to come to Penn, you'll find this office on the second floor of the town building. This here is the Donna Hampton study space. And again, it's was envisioned from the beginning as a place that was going to be welcoming to students, both undergraduate and graduate. We have facilities in there to sit down. There is in fact a couch, which is extremely well utilized. People use these space a lot for studying between classes, meeting people. There are facilities if you want to have a small meal. We do a lot of things with this. It's also a where our staff have their offices, so that allows for a really natural interaction between students and staff. So we sort of get a chance to know people. We also have the Cora Ingram conference room, which is heavily used by a number of our student organizations for a variety of purposes. And it's a great space overlooking Furness Design Building on the other side. So our ODI office supports a number of different initiatives. So we have, for instance, regular graduate student seminars covering everything from financial wellness to how do you go about starting research. Last week, we had a series of seminars looking at various aspects of work-life balance and the like. We hold weekly academic office hours. We've had yoga groups and various things that we think that our students tell us that they would benefit from. We're kind of open to suggestions for. It also, of course, serves as a meeting place for many of our student organizations, as I mentioned, the Society for Hispanic and Professional Engineers, NSBE, Association for Women Engineers. We have a OSTEM group, and again, our vision for the space is that inclusion is very important. So this is a space that's available to all of our students, and we want to do our best to support people as they go through their graduate career. Another initiative that we've had for a couple of years is the Joseph Bordonia Forum. And this is an event which focuses on issues at the intersection of technology, education, and society. So we've had 3 speakers. Our most recent was Dr. Gary May, who's actually the chancellor of University of California at Davis. We have another one upcoming next February. And we just sort of look forward to sort of continuing this conversation about how we in technology impact society and various ways that we can think about the impacts that we have. We have a number of external partnerships. So, for instance, we are been foundational members of the National GEM Consortium, which provides scholarship opportunities. The Lou Stokes Alliance for participation. There's a LEAP Alliance, which actually joins us with the top 20 CS granting PhD granting institutions across the country. We're a member of a Ivy League group that unites engineering schools across the Ivy Leagues. and a variety of others. We're actually very proud that we were, again, a founding member of this Ivy Engineering graduate group. We hosted the very first Ivy Engineering Graduate Symposium last year, which brought together students from across the Ivy Leagues. And we had a symposium where people were able to present research. We had a variety of workshops on a number of topics, from applying for jobs in industry to jobs in academia to various approaches to thinking about the research process. It was a great deal of fun. Actually, last week we had one of our second events, which was focused on the academic job search. We brought together, again, students from across the Ivy Leagues. It was a really great event. People were able to talk to people who had gone through the process, ask questions, hear different perspectives, think about how this might apply to their own career. Another thing that I'm sort of quite proud of is that our office is one of the hubs for outreach in the School of Engineering and Applied Science. Not the only one. There's great efforts in outreach from our LRSM, from GRASS, but from a number of other entities. But we've sort of taken this as definitely part of our mission. We see ourselves as having a role to play in the city of Philadelphia in terms of STEM education and exposing what we do to students throughout the K through 12 system, particularly in the school district of Philadelphia. We have entered into a partnership with Heights Philadelphia, which serves actually a wide range of students, preparing them for college. And that's led to a number of different programs. I won't do justice to all of them. This is one effort that is currently housed out of our office, which is the Penn GEMS program, focusing on K through 12 students, providing them with a summer opportunity. We have the Blended Learning Initiative, which actually goes over term time as well as over the summer period. We've had, at this point, several hundred students who come through and take courses in science, technology, engineering, and math, a lot of programming. We prepare students for AP computer science exams using materials that were developed by Eric Fu, who is a professor here at the School of Engineering and Applied Science. We have a number of different summer opportunities, including funded opportunities that we've gone out and raised secured support for, so that we can offer internships, research opportunities, courses of all kinds to students. So just as for instance, this over the couple of weeks, we'll be kicking off our 5th STEM Academy, which focuses on providing after-school activities to students in the middle schools. And this involves on the order of 80 students from Penn who go out on a weekly basis and mentor students in their classrooms. Many of those students who do this are actually graduate students. These are actually paid opportunities, but really people do it because they are interested in giving back in different ways. So just mentioning it, if this is something that's interesting to you, we are always in the business of sort of publicizing the various opportunities that people have to get involved if they have time. But I think a lot of people also find that this is sort of either a useful way to supplement their research or sometimes a needed break. So with that, I think I will leave it there for now, and happy to take any questions or allow the program to go ahead. Again, Christina.
Hi, CJ.
Hi, Laura.
Hi there. How are you? You went through definitely the essence of what our office covers and things like that. I know we only have a couple of minutes left. I did see a question in the Q&A about people being required to teach. And how does that work for graduate students, or would that be covered later on?
Yes, thank you, Dr. Stubbs. Actually, there's going to be afternoon sessions that are hosted by different doctoral programs. So those questions will be answered. So I did answer that question that was posed in the QA feature. So regarding teaching practicum, you'll learn more about that in the afternoon session. Most of our doctoral programs do have a teaching practicum requirement that is a major component of the doctoral program. So hopefully that answers your question. And thank you both for being here, Dr. Stubbs and Dr. Taylor. If you guys want to stay along to answer any ODI related questions in the chat, you're welcome to do so. That's all that I have for you today. So I am going to stop recording right now